Okay, let's hide this and hope that it all holds together. Okay. Um, yeah, as Bill was mentioning, you are my third presentation, so I don't get it right this time, then 3 strikes and you're out. But I think so. And the way that this kind of came about is I write articles, tutorials and such for a couple of online sites. For a while, I was writing for one called Improve Photography. And I wrote 32 articles for them, and they're still out there. And for the last couple of years, I've been writing for another one called Digital Photography School, interestingly enough, based out of Melbourne, Australia. Long story how I got hooked up with them, but that's for another time. Anyway, I've written 54 articles of this as of now. So all told, I've got 86 articles out in the cloud, which you can look up on a variety of different topics and learn a lot of stuff. And what you're going to get tonight is kind of a mashup of 2 of the articles. And the way that the whole presentation came about in Canada was up at the Calgary Camera Club. Apparently they were looking for a presentation on light and color. And the guy Googled it and up came one of my articles. And the next thing my phone rang and he said, "Can you do a presentation for our club on that?" And I went, "Well, I guess so." So I put this together. And so don't worry too much about taking a lot of notes because this is in article form out in the cloud and I'll give you the links to that. So don't worry too much about that. So this was the title page of one of the articles, specifically about how to understand light and color to improve your photography. And that's what that little DPS logo is that's Digital Photography School. So one morning, I got up and I was getting my morning coffee. And the night before, I had set a little rose in a vase out on the windowsill. And when I got up and got my coffee, the morning sun, my kitchen faces east and the morning light comes in. And I kind of saw what was happening on the kitchen counter. And I went, well, that's kind of cool. So I moved the vase to a different place where the light was also coming in the patio door. And I got my cell phone and I made a couple of shots. And I will often do that, just kind of almost use my cell phone as a test to go, is this worth making pictures of? And if I get some good results, then I go get my real camera and make pictures. And so that's what happened here. So the photo on the left was the setup, and I went and got a piece of mat board just to see how it would drop light and shadow on the mat board. And I went, okay, I'm kind of liking that. So the photo on the right is a little bit more edited version, but very often that's what happens, or it should happen to you as a photographer. You need to become an observer of light. Whether you have a camera in your hand or not, start watching how light behaves, what it does. And what you're going to get tonight, yeah, hopefully you will learn a few things, but even more so, I want you to pay more attention to light and become an observer of light. Sure, go ahead. Kill the lights? That's great. Become an observer of light. Canon actually has something, and you probably have heard about it, called Canon's Explorers of Light. Playing to the same theme. So if nothing else tonight, I want you to come away more conscious and aware of light. This guy, his name was George, and George had this quote about photography. He says, "Light makes photography. Embrace light, admire it, love it, but above all, know light. Know it for all you're worth, and you'll know the key to photography." Now, if I tell you that the guy who came up with this, his name was George, that may not mean anything to you. But if I tell you his last name, you'll probably know who I'm talking about. George Eastman. Anybody heard of George Eastman? Yep, George Eastman, the Kodak guy. This is his quote. And I kind of figure if George figures light is important for me to know as a photographer, that's a pretty good source. George Eastman, his claim to fame was prior to him, most photography was done on sheet film. And George kind of was the father of roll film, and then later inexpensive roll film cameras. And their slogan for Kodak was, "You push the button, we do the rest." And now, you know, for a long time, The yellow Kodak box was everywhere. They were top dog in photography. It's a shame they kind of dropped the ball when digital came along, and now, you know, not so much. But George knew what he was talking about. So this was continued experiments that same morning as the rose. I went, well, I like what the sun's doing and I like what it drops. So I went and got some glassware, filled it with colored water, and continued to play and see what light would do. And a little bit more, this time with the white mat board, kind of looking at how light was playing in shadows and so forth. So let's learn a little bit about light. I'm going to ask you to use both sides of your brain tonight. Hopefully nobody gets hurt. But, you know, we talk about left brain and right brain theory. And if I remember right, left brain, I believe, is the creative side. Right brain is the analytical side. Correct me if you know better and I'm wrong, but I think that's right. As a photographer, you got to use both sides of your brain. You know, the mechanics, the f-stops, the shutter speeds, all the calculations you do. That's right brain analytical stuff. Making photographs is left brain stuff, creative. Good photographers use both. So let's put you on the right side of your brain for a little bit and talk about what light is. Light is photons of energy. Photons, I don't know what photons are. The only time I'd ever heard about photons is when Captain Kirk fires the photon torpedoes, which I guess must be light-based or something. But they tell us that light has both wave and particle properties. And you will hear of something called the electromagnetic spectrum. And our human eyes can only see a little bit, a little tiny portion of the electromagnetic spectrum. Some photographers can go a little further. They use infrared photography. That's a little farther toward the red side of the spectrum we can see. And we can use ultraviolet light sources to go a little bit the other way. And then some guys, doctors primarily, also take pictures that we call X-rays. That's a little farther into the spectrum. So let's take a look. This is the electromagnetic spectrum. And it goes all the way from what are called long waves. Radio and television waves are part of the electromagnetic spectrum. Microwaves, just like you cook dinner with in the oven, that is a type of light energy that is in the electromagnetic spectrum. Infrared, we get into here, and then this little tiny portion is what we call visible light. That's what our cameras can see, that's what our eyes can see. And if we were to expand that out a little bit more, that breaks out into this, which you've seen before, with a prism, a rainbow. What that's doing is breaking light up into its component colors. And then you get up into ultraviolet and X-rays and gamma rays and all those other things. So do you care? Well, it's interesting. But what's interesting to me about it is, as a human eye or a camera, we only see a tiny, tiny little portion of that whole electromagnetic spectrum. So let's talk about the properties of light. When we think about light, we refer to its properties. One of those is quantity. How much? We use terms like intensity or brightness. How bright is an object? How dark is a light source? Those are quantity of light. Quality of light. And as photographers, you'll hear the terms hard light and soft light. It's really not hard light or soft light. What's hard or soft are the shadows. So when we talk about hard or soft light, that is a function of several things. Let's talk about hard and soft light. Today, we finally got to see the sun, which was pretty nice. Hadn't seen it in a while. And if you were out and about and the sun was shining and you looked at shadows, you would have noticed the shadows were what we call hard shadows. Now, why is that? That's because the sun up in the sky is it's obviously tremendously huge, well beyond the size of the Earth. But as it appears in the sky on a cloudless day, it's a tiny little pinpoint of light. So that little pinpoint of light relative to what it's shining on here is really small. So the hardness or softness of the shadow is a function of the size of the light source relative to the size of what it's shining on. So this little pinpoint of light up in the sky called the sun is relatively small compared to, say, me standing there. I look down, my shadow on the ground is going to be hard light. But let's think about another way that that works. How about on an overcast day? What is the light source on an overcast day? The whole sky becomes the light source. Now, the sky relative to me is much larger, so the light is soft. It's diffused with soft light sources. No, but I'm going to get into that in a bit. So let's move on from that. Oh, let me talk about one more thing, and we may circle back to that again. So let me ask you a question. Say I'm a studio photographer, and I'm taking a picture of my model here, and he's sitting in the chair, and I've got my light on him, and I look at that, and I take his picture, and I go, you know, the shadows are a little harder than what I would like. I'd like to soften up the shadows. Do I want to move my light source closer to him to soften the shadows? Or do I want to move my light source farther away from him to soften the shadows? How many say closer? How many say farther away? Okay, about 50-50. The answer is closer, because the reason being is when I move the light source closer to him, now the light source is larger relative to him. Does that make sense? If I took the light clear across the room, now the relative size of the light is smaller.
Your quantity is greater, but your quality is
Correct. It's the quality will be different. So let's talk a little bit about why that is, and that's the next thing, direction. Light waves travel in straight lines for the most part. We're going to talk about when that changes. But if my light source is here and it's hitting him here and it's closer to him, now the relative size makes the source bigger, and now light can come at him from different angles out here as opposed to here. Make sense?
Say that again.
Okay. If my light source is close to him, say my light source is this big, we'll just make believe. If it's close to him, now, because light travels in straight lines, it will hit him here, but it will also hit him here and here. If it's way back here, all the rays are hitting him here. It's like this and this, basically. No, not the intensity so much, the size of the light. And I'll get into that a little bit more with a different illustration. But I said light travels in straight lines, but it can be bent in what we call reflection or refraction. Reflection is basically how we see everything. Light goes out. Right now, he's sitting here. That's what you get for sitting in that seat. I'm going to be picking on you. The light primarily that's hitting him is a reflection off the screen, right? So what I see, and it looks kind of like you're wearing a yellow shirt, the light's coming from here, it's hitting your shirt, and it's reflecting back to my eyes, and then I can see it. And the reason his shirt looks yellow is because the shirt is absorbing most of the wavelengths of light that are colors, green, blue, red, but the yellow colors are reflecting back to me. So the reason anything is any color is because that is the color of the light that it's reflecting back to you, if that makes sense. That is why on a sunny day, if I have a white car and I have a black car, which car is going to get hotter quicker? The black car, you know that, right? And that's because the black car is reflecting very little light energy back. It's absorbing most of the light. And so therefore it heats up much faster than a white car that's reflecting back most of the light. Okay? Same premise. So that is reflection. Refraction is what's going on in that little dewdrop. And what also happens in your camera. When the light comes in the lens of your camera, it comes in and actually the lens will invert it. And back in the old days, if you ever shot with a view camera that didn't have a viewfinder, had a big ground glass on the back, and the guys threw the hood over their head and they would look in the ground glass, the image was upside down. And if you look in the dewdrop, the image is upside down. because that little drop is acting as a lens. And modern digital cameras, when the light comes in through the lens and hits the sensor, it's upside down. The only reason you see it right side up is the camera flips it. So that's refraction. The other thing you'll sometimes observe with refraction is if you take a glass of water and put a pencil or a spoon or something in it, it's going to look like the handle's bent. And that's because the light comes through, is changed by the density of the water versus the density of the air. The water changes the way the light behaves. So that's reflection and refraction. I have a hard time saying those. The other thing light can do is it can pass through transparent or translucent objects. Transparent objects are things that the light passes through with very little interference. Window glass, your pair of glasses, things like that. Translucent is like frosted glass or things like that, where the light gets through it, but it's broken up, it's diffused. And I'm going to show you a picture in a minute of backlit leaves. The leaves are translucent. The light comes through them, but it's broken up. Light can reflect or bounce off an object. We talked about that. We use a term for highly reflective objects. We call them shiny. And if they're really shiny, they may produce what are called specular highlights. Specular highlights are little pinpoints of light. And I'll show you a picture in a minute where we'll have some of those, but they're little hot spots, basically, of shiny objects. Objects that aren't very shiny are sometimes a term that we use that is called matte. Matte objects very much diffuse and break up the light, and it's reflected in lots of different directions. The other thing that light can be is scattered, which is diffusion in part. It can be absorbed. We talked about that, the black car, the white car. It can be refracted or bent, or it can cast shadows. All shadows are is a place where the straight line of light can't get through, and so behind it is dark because it's blocking the light. So that's, when we talk about light, think simultaneously about shadows, because that very often is a key to light. When you look at a photograph and you want to later analyze where is the light coming from, look at the opposite, look opposite the shadows. Wherever the shadows fall, the light is opposite that. You've seen rainbows, and you may have played with prisms. That is what's called dispersion. And what it's doing is just like when I showed you the picture of visible light, it's breaking white light into its component colors. Rainbows are individual water drops that are acting as prisms that break the light into its various colors. And then something else I think is just cool is the speed of light. And what was I going to tell you here? Oh, yeah. You probably have heard light travels faster than sound, 186,000 miles per second. That's why when you go out in a thunderstorm, you'll see the flash before you hear before you hear the boom, because light travels faster than sound, a lot faster. So you're going to see the flash and you'll hear the boom afterward because it takes the sound much longer to get to you. The other thing that's interesting about the speed of light, when we look at the sun, the light that left the sun that we finally see in our eye took 8 minutes and 20 seconds to get to Earth. And that seems like a while at 186,000 miles a second. But the nearest star to us, which is Alpha Centauri, when you look up in the sky, and if you were to look at that star, that light took 4 years to get here at 186,000 miles a second. And at night, if you're an astrophotographer, you are probably looking at stars that you can go out and see that the light took thousands of years to even get here. And they tell us now that some of the most distant stars that we can observe with telescopes, the light is over 9 billion light years away. I can't even get my head around that. That's, stuff that we can observe has been gone for a very long time, yet we still can see it. Crazy. Anyway, photography comes from two words. The word phos in Greek means light. The word graphos means writing or painting. So phos graphos is where we get the word photography. And most of our light, general photography, as I said, works within the visible light spectrum. And we use something called Kelvin temperature to describe the color of light. And you use this all the time as a photographer because you white balance your camera. Light is not created equal. Different kinds of light have different color temperatures. And what you're doing when you adjust white balance is you are correcting for different kinds of light. The human brain does that on itself pretty good. If I look at this white piece of paper, I go, well, yeah, that's white. If I took a picture with the camera and I didn't white balance, depending on what the light source was, it could be all kinds of different colors. So when we white balance, we're compensating for that. So here, I took a picture of this scene, and the bulb in it is what is called an Edison bulb, which is the old-fashioned filament type bulbs that Thomas Edison invented, and they're very warm in color, probably about 2800 K on the Kelvin scale. Now, if I had wanted to, I could have made the book, whatever that is there, white. And all I would have done is white balanced on that. But I didn't want it to be white. I wanted it to be warm colored. So I purposely white balanced it this way so that it would look more antique and warm, and it would, you know, communicate what I wanted to show in the photo. Color models. In photography, we work with two different color models. Mostly we work in what's called the additive color model. Your camera, your monitor, the projector, electronic sources that we see work in what is called the RGB color model. RGB, red, green, blue. If I took a magnifying glass and I looked really close at my monitor, or do it on your TV set or anything like that, the only three colors you're going to see are red dots, green dots, and blue dots. Every other color is made of various mixtures of those colors. And because to get white light, when we combine all colors together, we get white light, or as those little triads, if that's what you want to call them, combining different colors of red, green, blue give us every other color. Ink, on the other hand, when we make a print, is subtractive color. We start out with a white piece of paper, and as we add various colors of ink, we change the colors that we can make. Now, you would think the three colors here could make black. Not quite. If you combine CMY, which is cyan, magenta, and yellow, you will get kind of a dark, muddy brown. It's not very pure. So printers also add black to help richen the colors. So that's why in your printers, we'll talk about CMYK color model. And your more sophisticated printers will have various nuances of those. They may have gray, they may have photocyan, things like that, but essentially it's the same. It's adding all the different colors of ink to get the color you want to make. This is what it would look like, for instance, for red. Now, in an RGB model, red is 255 units of red. There is the color red. No green, no blue, just red. But over on the CMYK slider, if you're printing to get red, you need magenta and yellow. Those two colors mixed together give you red. The 255 here on the RGB slider, if all three of these were turned up to 255, what color would I get? Somebody? White. I would add all three colors at full intensity together and I get white. Now, if I take 255 and this was 255 and this was 255, and I go 255 times 255 times 255, what would I get roughly? 16 million and some odd, right? That's how many different colors you can get out of that mixture by combining those at various intensities. And I'm going to get a little lost here. I think that's what's 24-bit color, but I'd have to look that one up. But if you hear that, that's talking about how many different colors you can get by mixing those. Okay, so how do photographers control light? Well, first, a little background. This slide was a presentation we did over on the Boise Club when we were talking about how to do three-point lighting for portraiture. So if you want to learn about three-point lighting, little shameless plug, the article that talks about this article is one of my, what did I say, 85 articles out there now? This is one of them. But when we set up in a studio, we can create our own light. We can transmit light. We have a light source. In this particular image, I have 1, 2, 3 speed lights lighting the source, a key, a fill, and a hair light. I'm transmitting light from the speed lights. We can reflect light, as I said. Now, in this particular one, I'm using a fill and a key. Say if I wanted to light this side of her face and I didn't want to use this, I could get a big flex fill and bounce or reflect light to that side of her face and not transmit it, but reflect it. It would come from this over here, hit the reflector, and light her up on that side as well. We can diffuse light. Here, to diffuse light, what I talked about, taking a small light source and making it a bigger light source, that's what I'm doing with the umbrellas. Now, rather than just a tiny little light source that's this big off the front of a flash, I've got a light source that's this big. And as I talked about earlier, if I shot the shot and I went, you know, the shadows are a little harsh on her face, I'd like to soften them, what would I do? Move the umbrellas closer to her. Okay? Or I can block light. Here, I probably wouldn't want to do that, but there are many times where you want to not have light fall on certain parts of your subject. Hollywood will use these kinds of terms. You'll hear what they call flags. All a flag is something that blocks the light. Barn doors on a light are a type of flag. You are basically using the barn doors to control the light and block it from certain areas. So that's a flag. You can have a freestanding flag. Even say I was taking a picture of this and I didn't want the light to fall on the background, I could set it up in such a way that I used this to block the light from hitting where I didn't want it to go. That's a flag. You'll also hear other terms, not so much in photography, but also in motion pictures, and we use them. They'll use something they called gobos. Gobos is a term that came from go between. Theater uses gobos a lot. What they will do is in a light source, they'll put in a pattern and cast a shape of a tree or a clouds or something on the back wall. That's called a gobo because it goes between the light and the source. Or the other term you may hear are cookies. Cookies is a shortened form of cucaloris. And cucaloris is another way you use something to cast a pattern. So for instance, I see Venetian blinds behind you. Say I'm taking your picture and I like the way the blinds cast a shadow on the wall. I could put those and put a light source behind them and cast a shadow, and that's using it as a cookie or a cucaloris. So, a little quick test. We talked about a lot of the principles of light, and a lot of them are present in that shot. Can you identify any of them? What kind of light are we talking about here?
Reflected.
Reflected? Where am I seeing reflected?
And reflected is at the bottom.
Down here off the table?
Yeah.
Yep.
And
Where's the light being transmitted from? And how do you know?
there's the both lights opposite.
Where's the light coming in?
From the right.
From the camera right, basically. These are Venetian blinds, same morning, sunlight's coming in here. The giveaway, which way are the shadows going? This way, right? So when I want to know where the light's coming, I look opposite the shadows. Okay. What about refraction? Any refraction going on here? That's why this crazy business is going on in here, right? How about specular highlights? What did I say about specular highlights? What are they? Little pinpoints of light.
The rim of the
There's a specular highlight there. There's one up here. There's probably a little bit going on here. Those are specular highlights. So anytime you make a photo, is the knowledge of this going to help you make a better photo? Maybe. You know, a little scientific knowledge never hurts. So, question?
How far away was your camera though?
Probably 4 or 5 feet, maybe. Not very far.
And you didn't use any other light with the light?
That is purely the sunlight coming in the blinds. No other light. Okay. So when nature lights the scenes, a lot of you are landscape photographers. You don't control the light, nature controls the light. But if you understand how light works and how to look for it and how to use it, it's going to help you do a better job, even though you may not have active control of the light. So let's talk a little bit about that. This particular scene was taken back, I don't think it was this last summer, but this seems to happen every year. We get this forest fire smoke that comes in, and pretty soon the sun starts looking like that, very like a red ball practically. Well, I'd been watching that for several nights prior, and I went, I got to get somewhere and take advantage of that. A good photographer anticipates the light. Sometimes you wait for the light. You have it in your mind, it's going to do this, and you get all set up and you hope that happens. And sometimes it does, and sometimes it doesn't. And that's photography. That's why we love it. It doesn't, you know, there's a fair amount of luck involved. But the other thing, in addition to the luck, is knowing what could happen and being able to anticipate it. And that's why you want to understand light as a photographer, so you can better you don't have to wait to go there. You've already seen the picture in your head. You've already figured out what it will look like, and now you just hope to set up the circumstances where if, you know, the angels sing and it all happens good, you regret what you had in your head. So that's what happened here. The light had been doing this with the sun going down every night. I went out to a wheat field out in Kuna, found the wheat stalk, and made the shot. Okay, when I did this for the Boise Club, we took a little quick break. Paul, we got anybody else we need to deal with out in Zoom land, or any questions or feedback from Zoom? If you need to talk to me and you're in Zoom, hold down your space bar when you talk and that'll unmute you. Anybody? Crickets? Okay, well, maybe you won't get a break. Anybody here need a quick break? No, you're good? All right, well, forge on. This is where I'm going to change gears a little bit and move into the color portion. And this was the other article I wrote that's out there on Digital Photography School, and it was specific to color landscape photography. But the principles I'm going to talk about don't necessarily just apply to landscape. They're kind of universal. So let's talk about color. Color evokes emotion. It's one of the reasons we like sunsets. Sunsets are pretty. They make us happy. I guarantee if you go out and take a pretty picture of a sunset and you post it on Facebook, you'll get lots of likes just because it's a pretty sunset. Not maybe not a very good photo, but it'll be a pretty sunset and people will like it. And one of the reasons they like it is because of emotionally how sunsets make us feel. The colors, the settings, the, you know, so forth. So when you begin to understand the psychology of color and how to use it, you begin to use a tool that's very valuable to you, and that's how to communicate emotion to your viewer. So let's talk about that. Here are some scenes, the one at the bottom corner you saw a minute ago, but these primarily work with one color. And just think about the color in those photos and how each one of those photos makes you feel when you look at it. How does yellow make you feel? How does orange make you feel? What about green? That's communicating in visual, in what I call visual vocabulary, which is a vocabulary you want to learn as a photographer. Here's what they tell us about colors, and I'm not going to make you read that real fast because I'm going to dig in a little deeper, but this is what they say about how different colors make us feel. Somebody who knows this really well Advertisers. Think about products that you know and why they have a certain color that's dominant on their label and what it is they're trying to sell you and how they want you to feel about the product. Think about right now, we're getting ready, and I've seen them before, and you're about to see them again with the political primaries coming up. We see a lot of red and blue on signs. Well, one of the reasons is obviously our flag is red, white, and blue, but blue and red communicate certain things. We're going to talk about those. So let's dig a little deeper. This picture I took, for a while I worked over here at Kendall Ford as a photographer doing website photos for their cars. And mostly these were just same old, one right after the other, the exterior, their interior. Quick and dirty, get them out, post them online so people could see what the cars look like. But occasionally a cool car would come in and the photographer in me would say, you got to make a pretty shot of that. Look at that. Isn't that neat? Well, this was a red Jaguar that came in. And, you know, when we think about Jaguars, Jaguars are sexy, they're fun, they're fast, and that's what red communicates. That's why we like red sport cars. They're exciting, they're important, they're passionate, they're angry, call to action. That's the psychology of red. The other thing I did in this shot, not anything to do with color, is I used a lot of diagonal lines. I set this at a diagonal, I set these at diagonals, I put this so that it formed a implied diagonal between the hood ornament and this guy down here. Diagonals are dynamic. I wanted you to feel the excitement and the passion of a red Jaguar. And then just to add to it, I call this one Raindrops on Red Jags, which is kind of a spin-off of Raindrops on Roses, you know, my favorite things. So that was that. Purple, same windmill as you saw in one of those other shots, but a little different time in the evening, the clouds started to go purple. Well, purple's a color we equate with beauty, exotic, royal. Think of kings and things that are sensual and luxurious. That's what purple communicates. Blue, shot this one out at the Oceanside Pier in California. Long exposure, wanted the water to get kind of misty and blurred. And it was getting into the blue hour. And small aperture, so I could make the lights do stars, but blue is calming and serene and trustworthy. It's all that I mentioned the political signs, a lot of blue on political signs, because politicians essentially saying, trust me. Whether you can or not is another story, but you know, that's what they're trying. So that's blue. Green is peaceful, tranquil. We equate it with natural and growth. Shot this in the backyard of hostas. And again, the raindrops, that's just kind of a thing that I like. So I shoot a lot of things with raindrops on them. Orange is a color that we consider fun and warm and energizing. In the autumn, when the trees turn orange and the pumpkins are orange and so forth, that gives us a certain emotion and feeling. Yellow is a color that we equate with being happy and sunny and bright and playful. When the sunflowers grow in my backyard, I get out and I must have hundreds of pictures of sunflowers because they're photogenic and they're happy. I like them. They're fun. Brown is earthy, grounding, strength, dependability. Well, you can't get much more earthy than cracked mud. That's pretty earthy, but you'll find brown in other situations, and that is what that color communicates. Black, obviously a monochrome photo, but black is a color that we equate with something that's mysterious and powerful and edgy. Think about the little black dress that women wear or the black tuxedos that men's wear. James Bond in his black tuxedo. He's powerful, he's so forth. That's what black communicates. White's clean, healthy, pure, sterile, cold. Medical people wear white. They want us to, you know, look to them that they're sterile, they're clean, they're maybe emotionless, I don't know. Okay, the color wheel. You've heard of the color wheel. The colors on one side of the wheel are what we call the warm colors. And then we have other colors that are the cool colors. In a photograph, warm colors will tend to advance or feel like they're closer to you, while cool colors will tend to recede and feel like they're in the background. In photography, we work in a two-dimensional medium, and we're always striving to try and make something look three-dimensional when we're presenting it in 2 dimensions. One way we can do that is use color, because the warm colors will feel closer and the cool colors will recede. Examples here where complementary colors are used. I'd have to go back to the color wheel, but the colors that are opposite one another on the color wheel are considered complementary colors. Blue and yellow are complementary colors, opposites on the color wheel. Nature gives us a lot of complementary colors. We have a blue sky and very often a warm earth or whatever. Top shot, probably that same evening out in the, well, not the same evening because the sky's too blue, but out in the wheat field again. Blue sky, golden wheat, complementary colors. The other shot down below, out on the beach in Bandon, sunrise, blue water, blue sky, orange tones in the sky, complementary colors. Golden hour at Little Redfish Lake up in the Sawtooths. If you get up early in the morning and you wait and wait, and you'll get to shoot a lot of blue hour stuff, but when the sun comes up and it just starts to catch the top of the peaks, you're going to get a little golden light and it mixes really nicely and you get complementary colors. Shot down below the Bruno sand dunes, complementary colors, blue sky, warm sand. Interestingly enough, this photo also uses what's called color contrast. If I took all the color out of this photo and make it black and white, the brightness, the tonality of the sky and the sand are very close together. They're not so very different. It's the color that's lending the contrast in that shot. And then another sunset, blue sky, golden light, complementary colors, orange and blue. We see a lot of complementary colors and other things. There's a reason probably that the Broncos like orange and blue because they're complementary colors. Red and green are complementary colors at Christmas time. Yellow and purple at Easter, complementary colors. We also have what are called analogous colors. Analogous colors are what we might call color families, colors that are close to each other on the color wheel. So yellow, green, blue, so forth. Those are analogous colors. This shot out at the Columbia Gorge, one of the reasons that that's such a cool place to shoot is there's green and blue for miles. It's just analogous colors everywhere you look. And when you go there, between the green colors and the water, it's very peaceful and calming. There's a lot of reasons for that, but one of them is what colors your eye is seeing, and they're analogous colors. Every now and again, nature will dish you up what's called a color triad. Color triads are colors that are equal distance spaced on the color wheel. So for instance here, orange, blue, green, and violet are a color triad. Here I have blue, green, orange, and a little bit of violet in this area. This is shot off Steptoe Butte up in Washington, waited for sunrise. One reason you're shooting there is the Palouse, if you've not shot there, is photographer's heaven. The rolling hills, the green, but when the light lights up like this and you get a nice color triad, you go, thank you very much, I love it. A little later in the day, the same morning, sun a little higher, but light's constantly changing and the colors changing. You won't be doing photography very long, and you probably have heard these terms, the golden hour, the blue hour. The golden hour, what filmmakers sometimes call magic hour, because it's a time that you can hardly make a bad picture. The color's so pretty and the light's so nice. That is probably when the sun is just crested and the light is really low and it takes on a golden color, very warm colors during golden hour. Blue hour is when the sun has, before it's come up or after it's already gone down and the colors cool and everything turns kind of blue. Now, one of the things that all the time I see, I'll go out and, you know, you'll go to the beach or you'll go someplace where there's going to be a pretty sunset and everybody and their dog is lined up with their camera, getting ready to take a picture, even the people with their cell phones, and they're snapping away and the sun's going down and the sun goes down below the horizon and they go, show's over, and they pack up and they go home. Dumb. Don't do that. You'll miss the blue hour. You'll miss maybe some of the best colors you'll get that night. So show's not over when the sun goes down. Stick around. I can talk about him. He's not here. You know my good buddy Dan Motaz probably has appeared. Dan is when I grow up, I want to be a photographer like Dan. But I'll go out and shoot with Dan and I'll go, okay, Dan, come on, let's go. It's done. He'll shoot until it's almost dark. And I'll go, what are you getting? It's dark. Come on. And darned if he'll come back and he'll show me a photo and I'll go, I should have stayed. I should have left my camera up, because he's still getting great shots. Cameras, especially nowadays, can do things with very low light that will just blow you away. So don't quit just because you think the light is gone. There's more to be had.
So early,
Huh?
you have hard and soft.
Okay, hard and soft light. Hard and soft light aren't a function of the time of day necessarily. Golden and blue hour is. Hard and soft light is a function of diffusion. So for instance, soft light would be something you'd see on an overcast or cloud day where your apparent light source is much bigger, the whole sky or the whole cloud versus that little pinpoint of light. This light here that you're seeing here, because the sun is still up here, is, where I'm standing is still going to be pretty hard, but off in the distance here where the mountains are blocking that direct sun, the light back there is softer. Does that kind of make sense? It's kind of a function of what's lighting. Say again?
Yeah, why is sunset, why is it better light?
Okay, why is the light golden or why is the light blue? Because Harold might help me on this one, but as I understand it, we talked about how one of the reasons is diffusion. As light comes through atmosphere, more atmosphere, especially like on a smoky, cloudy day, more of the wavelengths of light are being absorbed, and therefore the only wavelengths of light you're getting are the warmer, the golden colors. It also has to do with the angle the light is coming and how the spectrum is being split up as to whether you're getting more of the color temperatures, the bluer colors versus the warmer colors, as I understand. There's also something a little related to it. I'm not going to go off in the weeds, but do a little research on what's called earth shadow. Earth shadow, very often if you take a picture of the right time of day, you'll see a band of blue and right above it a band of like magenta. And that is essentially the shadow of the earth way out there, where the sun, the earth is casting a shadow. So I don't have an example where I'd show you. Okay, let's keep moving on. Top picture is Arches National Park, golden hour. This one in the morning. Bottom shots, same exact location. Some of you may have been here. This is real close to Steptoe Butte. In fact, in the background in this picture, you can see Steptoe Butte in the background. So I'm not up on the butte, I'm down on the flat, looking back the other direction. And we went out there and waited for sunrise. And here the sun just started coming up a little bit, golden hour. Here the sun got a little higher. You can see the sun's now up about here, and the light started to cool. That warm golden light started to dissipate. So these are only 10 minutes apart, but look at the difference in the color of the light. Now, the other thing important, if you're not shooting raw, you're missing the boat, because the one thing raw allows you to do is adjust white balance after the fact. If I didn't get the white balance exactly what I wanted in camera while I shot it, no problem. I just fix it later and edit when I edit it in raw. And that's a little bit of what's gone on here. I wanted this to be warmer. I wanted this to be cooler. And so when I edited them in post, I purposely played with the white balance a little bit to bring out the warmth here and bring out a little more blue in this shot. Same sort of situation. These two are at Yellowstone, a geyser called Grand Fountain. These are probably taken 20 minutes apart. The first one in this one was when the sun was a little higher and the light was still pretty blue, but as the sun began to get down into the golden hour, it began to warm up. And again, I helped it with some additional editing when I edited it, warmed it up. These are all blue hour. Top shot near Island Park. The moon was out, the light was very blue. The only difference here, I've got two colors of light. I've got the blue sky, but notice how much warmer it is under the bridge. Light painted with a flashlight. So a flashlight normally is going to be a lot warmer than daylight. So that's going to add some warm colors here. This one you saw earlier, blue hour. Over in this direction, the sun was still peeking through the cracks a little bit. It's a little warmer over in that direction. And then, of course, we got the light reflections on the water. Guffey Bridge over at Celebration Park, blue hour. Swan Falls Dam, two kinds of light going on there. Blue hour, which is the daylight, and all the warm tungsten light that lit up the dam. Very different colors of light. Now, I could have played with the white balance all kinds of different ways and said, I don't want that golden light. I want it to be neutral, and I white balance for that. And things are going to change. But here, I liked it because golden, blue, yellow, blue, complementary colors. Think about the time and the season and the time of day. That's going to change your color of light. This one also shot out off the Oceanside Pier, the same pier you looked at, but this during the middle part of the day, very blue daylight. If people tell you you can't make photos in the middle of the day, that, you know, put your camera away and go take a nap during the middle of the day, well, you know, sometimes that's when you're there. You know, you won't be there when the golden hour, the blue hour, all the pretty light happens. So, you know, you got to take what they give you. So I went out here, walked out to the end of the pier, saw this guy coming sailing by in his sailboat. Well, that's a cool picture. Small f-stop. This is f20. If you look down here, you'll see all the settings, which just a side note, my editor at Digital Photography School wants me to put all my camera settings on my photos. So if you go out and look, it's a great way to learn what did the photographer use here? Why did he use that? And so forth. So that's helpful. Anyway, sailboat comes sailing by. I went, that's cool. I like that. I even kind of like the sun flare that came down here. I'm snapping away. And here comes this guy from over on the side flying in on the parasail. I went, oh, great, perfect. You know, so I called this one Sailing the Sea in the Sky. This one is out at the little ponds over here in front of Cincy. Smoky forest fire sunset. Knew it was going to be a nice warm golden sunset. Wanted a reflection. Didn't want to have to drive a long way. Find some places nearby that are your go-to spots. So when all of a sudden the light is pretty and you go, this would be a great evening for some photos. You can get there in 10, 15 minutes. You know, and it doesn't have, if I didn't tell you where that was shot, you don't know that that's the pond over in front of Cincy. Doesn't matter. It's just a pretty location to take a photo. How does this make you feel? What does it communicate? You feel cold? Cold. That's exactly what I want it to feel like. That is up. If you haven't been up near Roseberry on a road called Farm to Market Road, going up in that's off that road. And there was this barn and the moon came up, a full moon that night, and it was cold, really cold, probably, you know, 10 or thereabouts. And it was cold and I wanted it to look cold. So I shot it like this. And when I edited it, I brought up the white, changed the white balance to make it feel even colder because that's what I wanted to communicate.
The white blown out, does it matter?
You know, you're probably right. I probably would have been better to pull that in a little bit. Good observation.
Does it matter?
I am, you know, it depends. If you want some detail in the snow, you know, I probably, in retrospect, would probably want to rein that in a little more. I don't like it to be purposely blown out. but good observation. This one was even colder. This was probably 10 below out in Yellowstone National Park. You see all the hoarfrost down on the weeds. When I took the picture, and I'd hoped they show up in the photo, but they didn't. There were little crystals floating in the sky that were like frozen fog. Probably was, because what this business is back here is obviously Yellowstone, lots of thermal features. So, you know, geysers and stuff going on. It's why the little creek isn't frozen, because it's just a little too warm to freeze. It's thermal water. So, but when you I took the picture, it was 15 below and super cold. And when they used the word that it was crisp, it was crisp. And that's the word I want that photo to communicate. Then here, the Chemist bloom up at, what is that? I'm trying to, what's it? You know where I'm talking about. You've been there probably. I've been there year after year after year, and I don't remember what year this was. Memory, I think it was 2017, but I may be wrong. But never have had a better year. Sometimes you just get lucky and it all comes together. What's frustrating is, and you've probably done this too, you'll call BLM, you'll call local people up there, you'll say, how are the Chemists doing? How do they look? You know, before you get in the car and spend 2 hours driving out there. You want to kind of know, is it worth my time? For whatever reason, they don't know. The people who, BLM, who makes their living being outside, doesn't know when the Chemists are good. You got to ask a photographer, because we're used to, you know, we know what we're looking for. But anyway, same thing. I wanted complementary colors. The Chemists are blue. The sunset was gold. Was I thinking about that when I made the shot? Not necessarily. But when I got back to edit it, I went, oh, look, complementary colors. The Chemists probably aren't that purple naturally. They're probably closer to like this little guy here, if you've seen him, very light blue. But I like them a little more purple, so what do they call that? Poetic license? So I made them a little more purple. If you like color, and I talked about how orange makes us feel, you got to go do autumn in New England. That was a bucket list thing for me, and I finally got to go a couple of years ago. And I will tell you, if you like autumn, you have not seen autumn till you've seen autumn in New England. If you've heard about it, here to tell you, it's a real deal. So get out there, but that's one of the reasons that we like autumn, is because the way those colors make us feel. You know this location too. Was driving up to see my daughter in North Idaho, really super snowy day. One of the difficulties of shooting this is when they plow the road, they don't put very many pull-off spots. And so to be able to get off the road and then walk get to this location is hard. And so you're parking a quarter mile up from the bridge, and you're walking down the shoulder, and you're hoping that nobody comes around the corner and takes you out while you're walking up the road. But, you know, if it was easy, everybody would do it. So the snow's snowing like to beat the band, and I'm looking over my shoulder for cars, but I was glad I made the shot. And the point I'd like to make here is a saying, and you may have heard about it: when the weather gets bad, the photos get good. So don't just be a fair weather photographer. You're going to miss out on some of the best photos because they won't have the emotion and the mood and so forth and so on. Same thing here. This is the Columbia River Gorge, a place called Vista House. Rainy, cloudy, stormy. And when I showed this whole presentation to the Calgary Club, they said, yeah, and you're going to see more, you really like to saturate your colors, don't you? And I went, well, yeah, I think so. But you know, comes a time where you don't want to saturate your colors, because muted colors communicate mood a little bit better. Postcard color is not always a good thing. I call it postcard color because it's the neon glowing colors. If you go pick a postcard off the rack somewhere, I guarantee the colors are going to go, oh, it hurts my eyes, man. The colors are so saturated. So know when to make your colors muted to communicate mood. Purples and the colors that communicates, same thing here. Two different locations, Yellowstone, saw the little bunny trail going off there, went, that's kind of cool. And that formed a nice leading line back here to where the sun was coming through the trees and casting some nice warm light on this pretty little Christmas tree that was sitting out here. So I got two very different colors of light, the shade, which is blue and cold, and the warm golden light coming in and hitting this little tree back here. And then when I edited it, I played to that even more. I purposely painted this in a little more to make it warmer and brought the blues up in this area to make them a little colder. Arches National Park, a lot of little wildflowers at the right time of the year, Indian paintbrush, just a little thing to think about here. Boom, your eye goes right here. First of all, it's in the foreground, but secondly, it's red. Red draws our eye right now. Red's very powerful. And so we use it. The only thing as a photographer to be careful with red is red will be the first color that will blow out when you take a picture of it. You can have a good exposure, but your reds can be overexposed. So pay attention to your histogram when you shoot something that's bright red, and don't just look at the composite histogram, look at your three different histograms, your red, green, blue histogram, and make sure you're not blowing out your reds. This one's shot in RAW. This is Trillium Lake up overlooking Mount Hood. If you were to turn 90 degrees to your left from where your view is in that shot, you'd be looking across the lake to Mount Hood. And that's what we wanted that morning, was a reflection of Mount Hood in the lake. Nature didn't play with us that morning. The mountain was clouded over and you know, you couldn't even see it. It'd peek out, it'd go back, never got a shot of the mountain in the lake. So when you get skunked, you keep watching around. Maybe your photo isn't here. Maybe it's over here. Sun started to come up, looked across the lake, mist on the lake, little dock, pretty colors, boom, there's my photo. So be looking around for stuff like that. And this photo straight out of the camera was like, nothing special. Sometimes you got to coax it out a little bit with some editing. And that's why shooting in RAW can be a really good thing. How am I doing on time here? I'm good? Okay. All right, this was on the way up towards McCall, a little bit of morning snow driving up, looked out across the field, and here was a red barn. And who doesn't love a nice red barn? This to me is a Christmas card. I really, you know, I think it is. Two reasons that this one works for me. Number one, the red barn is just the red says, here I am, and it draws your eye right to it. Red and blue are opposite each other on the color wheel, so that works. And then compositionally, this is on a PowerPoint. Third line here, third line here. PowerPoint right there. So that's the rationale for that, and so forth. Color is not always something you want to use. This one is up in the Eastern Sierra. At about 10,000 feet, grow the bristlecone pines. They tell us that the bristlecone pines are the oldest living things on Earth, like 5,000 years old. And that gnarly tree that you see there is still alive and has been growing for 5,000 years. Blows me away. The tree was kind of a tawny brown color and the sky was blue. Complementary colors. It makes a nice color photograph. But what I wanted to communicate here was the gnarliness of the tree and the twisted shapes and all that kind of stuff. And color just got in the way. So sometimes, yeah, you can use color to communicate, and you should, but sometimes you go, you know, I maybe want to think about this as a monochrome. And if sometimes you're working with a photograph, it's usually a click to say, how would that look like a monochrome? And you may be surprised. You may go, whoa, that's much better. I don't need color here. Here's an example. This is called the White Rim Trail in Canyonlands National Park. This little Jeep trail hangs right on the edge of the cliff. And you don't want to be looking at the scenery too closely and not pay attention to what you're doing, because if you go miss the corner, it's a long way down, like clear down to where that other part of the road is down there. So we didn't drive it. Guys with the Jeeps like to go out and drive this and so forth. But color or monochrome, is one better? Now you may say, well, I like one better than the other, and that's okay. but they communicate different things, and they're just different. So try both your images, or try your images in both realms to see what you like. You got to help your images speak. Make believe your image is on the wall of a gallery and you're not there, just your viewer is going to be there. You can't explain it, you can't interpret it, you can't defend it. It's got to talk for itself. And so think about, what do I want my viewer to see? What do I want them to think, feel, hear, smell? Smell. Experience. Okay, smell. Say I take a picture of a dead, stinky fish and he's nasty looking and he's rotting, and I take a picture of it. Can you smell the photograph? Bet you can. Bet you can. So use your visual words. One of those is the language of color. Use all the visual vocabulary you can to make your images speak for themselves. Here's some things you can do to make enhance your skills. Seek out light and shadow. And sometimes do it without a camera. Many has been the time that I've just gotten up, got my morning coffee, sat in my recliner, and all of a sudden noticed the way the light was coming in to the room through the blinds, or been in another location. Learn to observe light. Back to what I said at the very beginning, become an observer of light, and it will serve you well as a photographer. Or take a photo walk and say, I'm not going to make a photo about things, I'm going to make photos about light and shadow. Wherever I find it, whatever it looks like, if I look at it and it's light and shadow working together, I'll use that to make my photograph. So try that. Same thing with color. Pick a color and make it your assignment. I did a project 52 one year, took pictures every week, had a deck of cards, and I can tell you about them later if you're interested, but in the deck was a photo idea, 52 cards in the deck. Every week at the beginning of the week, I'd pull a card, I'd look at it, I'd go, here's your assignment for the week, and that's what I would make photos of. Didn't pull a card out of the deck until I had finished one project and it was a new week, so I didn't know what was coming. It was always, here it is. Oh, your assignment this week is the color blue. Okay, what do I do with that? Well, that'll teach you to see things in a new way. If you want to take that a little further, consider, like I said, color, but how about if you made photographs that communicated an adjective, not a noun, not a place, not a thing. Make photos that communicate hot, that communicate cold, exciting, peaceful, inviting, sensual. Come up with a verb and say, I'm going to make photos that communicate that. And don't always be completely literal. Okay, so I make a photograph that communicates hot. Well, I don't have to show a branding iron or a match or whatever. How about if I had a picture of a guy sitting there and the sweat was just rolling down his face? Would that communicate hot? So stretch a little bit. Think how I'm going to use my visual vocabulary. Or hot, something that's red, that's orange, that's glowing, that, that's going to communicate hot. So think about how you can communicate with your visual vocabulary. Here are some examples of light and shadow. Walking along, saw the shadow that the fence was casting. These snow mounds on the fence were interesting, but what caught my eye was the shadow. This one, backyard patio, chair on the patio, dropped some really interesting light on the pavement. Well, that's kind of cool. Big metal tank, in fact, probably over here in Meridian, whatever that place is where the feed elevators and stuff are, there's some big tanks. Late in the afternoon, bolts on the side of the tank are casting interesting shadows. Morning in the room where I'm sitting with my coffee, I have a door that has panes of beveled glass in it. So the light's coming through that. The shadows are blocked light where the dividers between the panes are blocking the light and casting shadows. And these patterns are where the beveled panes are breaking up the light and casting that. An abstract. Light through the Venetian blinds hitting the wall on a piece of furniture. We talked about the Palouse. One of the reasons we shoot up there is it plays so fun with light and shadow. Was playing ping pong the night before, got up the next day, opened the garage door, the light was low, came in, cast that, and I went, that's kind of cool. Had an assignment to go out and shoot these ballerinas, and it got late in the afternoon and the shadows were really long. So this is as much about the shadows as it is the dancers.
Beatles.
What's that?
Beatles.
The Beatles.
The Beatles.
Oh, the Beatles, yes. Oh, like Abbey Road, yeah, yeah. This is out of Kleiner Park. The assignment, light and shadow. That was one of my Project 52 cards, go shoot light and shadow. So I'm looking for shadows, lots of metal fences there that cast these patterns, or the benches, or both. This one, I had seen people taking pictures of forks, and I went, forks, what can you do with those? So I thought, I'll play with that for a bit. Well, it cast this shadow, and I went, wow, look at that. What does that look like? Does anybody else see what I see in that photo? What do you see? A hand? What else?
That's great.
Maybe. But what this looks like to me is a hand strumming a guitar, right? These are guitar strings. That's just what I see. But that's, you know, it's fun to play with light and shadow. This is the bridge that goes over the Boise River down there. Is that Merrill Park in Meridian, I believe?
Yeah.
I think, yeah. Color. Got some kiwis, put them on a Pyrex pie plate, put a light underneath so they're completely backlit, sliced them thin. So all that is completely backlit. Bought some flowers. Before I planted them, made some macros with the cell phone. Cell phones actually take pretty good macros a lot of times. Harold mentioned doing an art or a presentation for you on macro. I just posted out on the digital photography site. It's my latest, an article on macro photography equipment, all the way from cell phones on through various other types of equipment, all up to what Harold's doing. And kudos to him. He helped me a lot with his article, went to his house, saw his rig, and some of his photos are in the article, close-ups of bugs and stuff like that. Blue Hour at Craters of the Moon. Backyard, lupin flower, I like the lines, the color. This and this, I shoot a lot of photos of the ballet. Some of the Boise club photographers have been out and shot with us because they invite us to their rehearsals. So we get a lot of good ballerina photos. And the purple tones, I was talking about purple and the color, what that communicates. Shot this one, did a article on using bubbly effervescent water to make photos. So these I put in a glass, let the bubbles build up on them. These are both backlit a little bit to get a little light coming through the fruit, and then front lit reflected to get light on the front. Underneath the sunflowers, when the leaves are just starting to come on, kind of looking up, this light is translucent. We talked about light coming through. Redwoods, the ferns grow like crazy in that type of environment. Green growth, what I communicated. Just up the coast from that, Brookings, Oregon, nice sunset. This is the scene if you go up to north central Idaho and the canola fields are blooming. And if God smiles on you that day and gives you some nice white puffy clouds, you'll go, thank you very much. And you'll get blue and you'll get puffy clouds and you'll get the complementary color of yellow. And this is a piece out of a panorama that, you know, I put in and it's like crazy big and wide. Played with a macro one day, put a match on a stick, put another match close to it, snap the shutter as it fired up. Shoot it a lot to get it. Make sure you put a UV or a protection filter on your lens so you don't screw up your lens if it flares badly and things don't work out good. So that's that. This is links, and I will provide these if you are interested, to where you'll find more of my stuff. Right now I'm writing for Improved Photography, 50 some articles out there. There's the big long URL. I'll put that somewhere where you guys can get to it. These are the older articles on Digital Photography School. I post a lot on Instagram. I've got 400 and some photos out there now. And if you flat can't find any of that, just Google me at R. Ohnsman If you forget how to spell Ohnsman, if this was a J, it would say Johnsman, but it's not Johnsman, it's Ohnsman, and R is Rick. So that's what I got for you tonight. Out Zoomies, did you get all that, Paul?
Yes, I got it.
Good. All right.